So, welcome to the Robotics and Artificial Intelligence Meetup number 19. And as we planned last time, today we will be deconstructing or reverse engineering a roomba. And this is part of the theme for this month, which is cleaning robots. And last time we just had an overview of the different kinds of cleaning robots that we had. And based on our discussions, we found that Roomba would be the most interesting to reverse engineer, and so this is what we are going to do today. And the agenda is very simple for today. So we'll first define the problem definition, which the engineers of Roomba might have done during the initial phases of its development. So the idea is that we'll kind of try to understand the way of thinking of how Roomba was developed, and we'll try to reverse engineer the whole thing as much as we can in today's session, and the rest part we can continue in the next session, or we can take one particular component uh, and dig a bit deeper into it. So yeah, and after that we'll have introductions and casual networking. So the timing is actually there's some mistyping here. So yeah, it would just be at the last 10 minutes of the meeting. So let's start. And for today's meetup, I'm trying to do it a bit differently, and I'll just write it on OneNote, and I'll try to draw things, because like when we are interacting and having these mutual discussions, it makes sense that like I write things quickly and draw things because this is more spontaneous. So let's see how this goes. Otherwise, I'll switch to PPT stuff. Let's see how many people have joined. Okay. Okay, all right. Let's start, and this will be very interactive. And I would encourage that you can you just contribute to it and speak whatever makes sense to you. So let's first define. Sorry. Okay, I thought someone said something. So let's first define the problem. So the first step would be defining the problem statement for a Roomba. What the problem statement would be. So it is the goal of Roomba is actually to uh, clean the entire room. Not sure if cleaning it most efficiently was also considered in that. What do you guys think? Sorry, you're not audible. Could you turn off your microphone? It- okay, I don't know what was that. All right. Yeah. So let's define the problem statement. So the problem statement, according to me, would be cleaning several rooms of the house. Actually, the covering the whole floor area as much as possible, covering maximum floor space in the most efficient manner, probably. Yeah. So let's get your inputs. What do you think the problem definition for a Roomba system could be? So just feel free to say anything that comes into your mind, because we have to have a mutually decided problem definition, so we can then try to deconstruct Roomba.
I think the very I think the important task would be to what would be path planning, mapping the area, and navigation and localization would be the most important task for the Roomba board. Then only it can carry around the cleaning part.
Yeah, so now what we are doing is actually we are defining the overall problem statement. So if the like what problem is it targeting, and then after that we will go into functional requirements. What what are the tasks and other things that it would be
Okay.
doing. So
General problem statement.
yeah, general overall. So we'll try to like go deeper step by step.
Maybe we can try to build a system where the Roomba is also able to climb stairs up and down and even clean the stairs if a system can be made such. We won't know. We are just defining a problem. That's all.
Move up and down. So like we are talking about like the current Roomba statement, the current Roomba, like what the problem statement for it would be. So we are just targeting this particular product, and we are trying to reverse engineer and think in the initial phases how the original the problem statement might have been. So we are kind of going in the reverse engineering direction and not trying to make a new product. So then we'll also consider in depth what are the actual components of the whole system. So yeah, just to clarify, we are just reverse engineering this whole thing and trying to deconstruct it from scratch, basically. Yeah, and so I think like we'll all agree. Probably it can be defined in a better way, but the goal is to clean the whole floor space inside the house and cover several rooms in the most efficient manner. Right? What do you think?
Yes.
Like, yeah. Sorry, Apurvi, you were saying something.
No, no, carry on, carry on.
No, just yeah. So this is what I wanted to say, and I want to know like what your views on that are, so we can fix this and move to the next step. Yeah, Subhashish, do you want to add something?
No, it's fine. We can proceed this way. I just posted some links in the like
Chat
background,
room.
and so I
Okay.
just heard somebody said like how this navigation works because it's different technology for different Roomba. So we
Hmm.
have visual SLAM plus we also have non-visuals like navigation normal SLAM.
Yeah, yeah,
So
yeah.
using these laser
Laser
sensors,
scan.
it does a normal SLAM, and using visual sensor, it does a V SLAM. So
Hmm.
these are two different technologies. So I think we
Yeah.
should cover the one which also has vSLAM, like the advanced ones with 980,
Yeah, yeah, yeah. Okay.
or maybe
Yeah, it would be better that we cover the one with the most features. Okay, so this I think there is like nothing to discuss much about the problem statement. Let's go to functional requirements. So functional requirements would go in the line of what are the tasks that robots should do, or what are the kind of features that it should have in a sense. So first is it should be like the most important requirement is cleaning the floor, and then it should have a power source, right? Charging module. What else? Like, feel free to say
camera,
whatever comes to your mind right now. What are
And
the, sorry?
a
uh,
camera.
A camera would be like a more, I think, more
More
specific
about
thing.
technical requirement. I think you
Yeah,
are talking about functional requirements. Functional is different than technical requirements. So
yeah,
Oh,
exactly. And in fact, I should not write charging module, a way to charge it or something like that. So,
oh yeah, that
charging system, maybe just let's write it.
charging station maybe it's
Charging
could be like
station, but that would be like,
docking port, docking station.
the with functional requirements, I think, and also like you guys can also share what you think. What I think by functional requirements is we have to keep it as unbiased as possible. So if I say, for example, instead of cleaning the floor, I say vacuum cleaning the floor or wiping the floor, then we are already kind of building some biasness that, like, we can, like, when we are in the conception stage of deciding the components, then we would not be thinking in different directions. So we want to keep it as uh, open ended as possible. So cleaning the floor could be in a multitude of different ways, right? And a power source is also pretty general. And then if we say like docking system instead of charging system, then we already have the image of the existing like system in our mind. So right now, like, we are assuming that initially when the product was not there, then they might be considering all the different possibilities. And this product that we have right now, this came only after a lot of stages of refinement. So yeah, that's what I'm trying to simulate in a small way.
yeah, right. The another thing, if you think here, if you think the product was not existing, then they would not be even thinking about the charging system because then you are assuming you are using batteries. So that is another
uh
thing because
yeah, that
if you
makes
think a
sense.
normal vacuum cleaner, it just plugs in. So
Hmm,
is it
hmm,
a pluggable, non-pluggable? Then again, you're going to second thing,
hmm, hmm,
right?
hmm.
So if you think about power source, then you will decide is it a battery powered or non-battery powered, like AC or DC. Then you think DC, then battery, then you go about charging concept.
Yeah, I agree. I agree. Yeah, you're right. So that is also creating a bias. So depending on the power source, when we refine it, and then we decide that, okay, do we need a charging module or not? Yeah, you're right. You're right.
I think important thing would be also like a portability. Like, will it be portable? Like in terms of dimension, this would be a functional requirement.
Yeah. So we'll be thinking also in terms of what would be beneficial to the customer. Why would the customer also want this, right? Uh,
Yeah, because do you want to carry it or just have it every the same place? Or and then another thing would be um, like functional requirement. Is it possible to automatically navigate? Because this is also like a feature here, or you want to manually navigate it, like navigation system of this. Because I think one thing you are assuming it will be a robotic cleaner, right? This is definitely like this
yeah.
assumption is there.
Hmm.
Maybe it's better to write in the beginning or somewhere assumptions. What are the assumptions?
I think let's not even keep any assumptions, but let's then try to let's try to arrive at this particular thing, and see along the way what assumptions might have been. Because maybe when they started, I don't know, were they thinking of a robotic vacuum cleaner, or were they trying to just
Yes,
build a
yes, yes, yes. They
device?
thought about because yes, they thought
Yeah.
about robotic because the history of it is they started
Okay.
from robots. Basically, they were a robotic company.
Okay.
What
Okay.
I mean, if you read the link I sent you, they began with normally creating robots for like let's say Mars mission, right? So they first started with legged robots, and then thought, okay, how can we use the technology of robotics into consumer robotics? And then they thought about vacuum cleaners. And then they thought about like going. So basically, their assumption itself it was a robotic system.
Okay, okay. So we can like make some assumptions regarding the company, and like this would be based on what sort of progress has been had been going on probably at the beginning of this particular project, that they were already an established robotic company and they were looking for a robotic project, right?
They're looking for a consumer robotic product. So
Hmm.
basically, they didn't have a product, they had the technology. They thought, how can we use all this technology, which is already functional, into a consumer robotic product? And then they thought, okay, this can be used into vacuum cleaners.
Hmm. Hmm.
Because if you think, if we are trying to think about optimizing a vacuum cleaner, then you would go in the direction of Dyson or like this handheld vacuum cleaners. But if you think about robotic vacuum cleaner, then you will go in a different direction. So it's very important to know what is your goal.
Okay, okay. So basically, you mentioned that they already had the technology, so they were driven by their technological
Yeah, right. They were driven by
capability.
technology because they first had the technology, then they thought about product, not first
Okay.
product, then technology.
Hmm.
They were like mostly engineers who started this.
Hmm. Hmm.
So
Hmm.
it was a different way they began this.
Okay, yeah, I think that's another important point to consider, that like what their mindset was at that point. So yeah,
Mm.
they were looking to make a consumer robotic product, and that could clean several rooms of the house, covering maximum floor area in the most efficient manner. And the functional requirement is the most important: cleaning the floor. Then we should have a power source, and it should be portable. Yeah, and what else? It should not it should not fall off some when there is an empty space. It should have a way of detecting that. It should first of all have collision detection, so it knows when it collides. And second of all, it should not fall off when there is, for example, no ground after a particular maybe there's stair or some step there.
And stair thing came afterwards. I think the first thing which was an assumption here was it should automatically navigate. So there should not be a manual thing which is like moving this. So that was the one of the most important assumption, that it's an automatic navigation system. So it
Okay.
will be vacuum cleaning, but it will do it by itself and it moves by itself.
Hmm. Hmm.
So
So autonomous navigation is also was they already probably had similar systems, and they wanted to implement this on this particular product probably.
and I think here one important is that it's like non-aerial, so it has to be like not real something which is flying. Because then if you think vacuum cleaners are also used to like use this spider webs and all that also, right? So on the walls. So this was also not the goal. The goal
But
was mostly on the floor.
like, don't you think this this could be like open in the beginning, and maybe this was rejected in the concept phase?
Yeah,
Maybe they,
right. Yeah, yeah.
maybe I don't know. Maybe this was this was also, maybe they had aerial concepts as well at that point.
I
And
think maybe that time 2000, it was like 1990 when they were like working on this. So at that time maybe the aerial robotics was not that famous. I think it was not even like, if you think drones and all, it started very late. So that
yeah.
time they didn't even, I think, maybe think about aerial robotics. So, but nowadays I think this option is already open, that Roomba flying.
Yeah,
So
okay. Hmm. Yeah, so so our goal today is to somehow arrive at this particular things. We'll also have like in the next step we'll try to think of other possibilities, but then here I have noted down some of the main features that Roomba exactly has. And
yeah,
we'll this would be like our main goal for today, to actually discuss these actual features. So let's let's quickly define these initial steps so we can go to this main part. Okay,
Yeah.
and yeah, for aerial thing, I think since we want to, since we also have limited time, we can keep it as an assumption, because we don't want to have make any extra concepts on that. Non-aerial navigation, we can say that. Okay, so portability is one requirement, and then yeah, since it is non-aerial and autonomous, we can say that it should uh, detect and avoid collisions in any way, and it should not fall off the ground, or I don't know. Uh, I think like a way to put it in an unbiased way would be um, to just define it as like
I think instead of avoid collision, you can name it obstacle avoidance system. Basically, this is a like a general term, right? Like it will avoid its obstacles by itself.
Mhm. But yeah, it's
So
the yeah same thing, right? Obstacle
yeah,
avoidance. And for preventing falling off an elevated surface, so I guess this can be just a safety of this particular thing, that is it should not be damaged somehow. Safety of the
so mainly it's like a safety requirement.
yeah safety of the robot. And what else? Another thing, it should be if it stops somehow, it should be able to yeah again, I think for safety, and if a human picks it, it should stop automatically. So all these things will be a part of safety, right? So
Yeah, so safety requirement. I
safety
mean,
of
if
the
you go to safety requirements,
safety of the
yeah,
robot
so
and safety of the human, I guess these two categories we can
yeah, yeah, right. Safety
divide
of the
it in.
robot, safety requirement. Very good. Yeah.
mm, what else can we define it? So we don't want to spend too much time on this. Anything else you want to add, Subhashish, or anyone else?
Baby safety comes under safety of the human now.
Sorry.
I mean, like, if
Krish, it's
the
not audible. Can you become close to the mic?
yeah, now.
Yeah,
Yeah.
now it's good.
Oh, okay. So it was blocking. Oh, okay. I was saying ye ki baby safety comes under safety of the human. Like if a baby is near that machine.
Yeah, I
Yeah, yeah.
think
It's
yeah.
Okay.
Safety of this thing, and then they yeah, I think rest of the things can be defined.
And height as well. I mean, it should not fall from some place.
Yeah, so again, that would be safety of the robot. It should not
Okay.
fall from a height, and it should also then stop when a human is picking, and that would be safety of the human. Yeah, okay, let's move to uh, the components. And of course, this is not like the ideal design pipeline, but we are also taking into account the limited time and trying to cover the main features. So components, or maybe let's write overall system. Yeah, overall system. So now we know that cleaning the floor is required for us. We need a power source, and we need portable. So in the overall system, we can have different possibilities, and here's where I can start to draw some things as well. So here is where we'll have uh, open-ended solutions. So different kinds of solutions for maybe power source, and the docking system that was originally implemented, or other kinds of possibilities that might have been considered. And here we'll have multiple different concepts, and then after that we'll have reverse engineering Roomba features, and this would be the last step. Okay, so overall system cleaning the floor. So our task is to clean the dust, all the waste and anything that is not that should not be there on the floor, and keep it on. And another requirement would be disposing of the waste, right? Disposing of the waste, or storing. Maybe storing is the better word.
Compartment.
Storing the waste, yeah, or compartment, yeah, exactly. Yeah, so let's talk about the cleaning of floor. What are the different ways in which different uh, which the floor can be cleaned, provided that we we are going for a consumer robotic product with an autonomous system for navigation, and non-aerial system. So non-aerial would be more relevant here. So here's where you can, tell me any crazy way of cleaning the floor, or anything that we have. And so like one obvious thing is that comes to mind is vacuum cleaning, right? And this is one way of cleaning it. And actually this cleaning system would also then be divided into sub components after we choose the kind of cleaning that we are going for. Vacuum cleaning, another could be just wiping the floor or something. Yeah, anything else? Like just think of like how floor is cleaned on an everyday basis. So if not, then we can go to the next part. Meanwhile, like if some idea comes, just let me know. And the next part of it would be simply power source. And power source could be just you know uh, um, a docking station kind of a thing, or
I think power source, you first have to decide, is it a DC source or an AC source?
Mhm.
That is the first thing.
DC source and AC source. Yeah, so now is where you can suggest options for DC and AC source. What kind of things would be there, could be there?
Maybe for DC source we can use a lithium ion battery,
Mm-hmm. Yeah.
but some might argue that lipo battery is better and stuff.
Yeah, so
Or is,
this evaluation would be the next stage. So here is where you can, yeah, that's why I'm asking to brainstorm, because here you can say anything, because this will be this is kind of the concept stage as we have in the design process, and then this would be filtered, and these concepts are evaluated at a later stage. So the
yeah,
idea is that like we don't restrict our imagination, because there because then we might like miss out some good solution. So we'll just write lithium ion battery, and for AC source is, yeah,
Like 230-volt supply, right?
yeah, the 230-volt socket, or just going to write.
In European countries, the main voltage supply is 230, so it's like 10 greater than in India. Why is that a reason? Because I have seen a lot many people they can't use appliances directly from India in cities abroad. I mean, they break down as usual.
Yeah, I don't know the reason for that, although I remember like uh, having read something like that, but I totally forgot now.
Okay.
Okay. I mean, we should have actually more concepts than these. Let's move back to cleaning of the system. So, vacuum, wiping, and what are the other ways that we clean the floor? I- If it is talking about cleaning, the goal is to, like, you can imagine taking off the dust. Uh, I mean, this would sound crazy, but burning the waste material, for example. Now, the reason why I'm writing this, even though this sounds silly, is to just demonstrate a point that in the concept stage, you can write all the ideas, and of course, this might be probably rejected due to a lot of reasons, but like to collect all the ideas, because like burning the waste is also a way to clean the floor, right? Okay, and
Should we have, I don't know, waste segregation in the robot itself? I think most of the waste would be dust, but there can be many other kinds of waste also, paper, or if it's cleaning the kitchen, there could be
segregating,
leftover. Yes, segregating the waste in within the
mm,
company.
that would
Another thing
be,
would be like, yeah,
I don't know. It sounds very silly and complicated.
no, it's
no,
actually an additional, I think it would come in additional features, I think, right? Subhashish, what do you say?
I was telling like important also to think about, will it only work on dry waste or dry thing, or is it also on fluid things? For example, if the
Yeah.
robot is cleaning and there is some kind of water or some kind of, let's say, tea spilled,
Hmm.
how
Hmm.
will it work in that case? Will it affect the system or will it not affect? Is it capable to handle, not capable? So
Hmm. Hmm. And
solid, liquid.
Wiping would do if
and
fluid is.
Yeah,
actually,
but
this considering this thing is also a very important point. So this would be so our assumption so far was it's dry stuff, right? Because we had this biased image of Roomba in our mind, but we want to keep it as unbiased as possible. So this thing is, we can define it in the problem statement that we want to we want to only target the dry waste, right?
yeah, solid dry waste.
Cleaning several room, or actually a more specific way to define would be removing dry waste from the floor, and we are only targeting floor, from the floor of the house. Yeah, anyway, yeah, so the good important thing is that we mutually target the same thing. So yeah, I think that's a good point. We are going to target just the dry waste, And so probably wiping is also not then a concept, right? Then it should.
Wiping could be a concept because if you think, let's say the robot has a system of using some kind of weight cloth or something inside. Basically, then in that case, it's not really having like liquid thing to clear. It's more about like let's say you have a solid floor, but you have some kind of wiping mechanism in the robot which just mops or wipes the floor
Ah,
using some
okay.
that is a moist cloth. But then that is a different concept than thinking I will clean up the spilled liquid or ketchup. That is a different concept, right? So
Yeah.
yeah, I mean both are possible, but then wiping doesn't always mean that you are talking about liquid waste.
Yeah, yeah, that makes sense. Hmm. So cleaning the floor, any other concept in this? Also, you can interrupt me if you can think of anything later as well. So portability, yeah, this is like we don't need to probably, we just need to keep it into account. I don't think we need to define multiple systems here. Collision avoidance systems.
So Chandan, so
Yeah.
what I think important in portability is the defining the dimension, like how much maximum size
Hmm.
this thing will be. Like this is also an important thing. Will it be like
Yes,
a
yes.
box of
Hmm. Hmm.
like
Hmm.
will it be a small dimension thing, like in the dimension of a box of 30
All
centimeter, or is it like a big thing or small?
Okay.
Like
yes.
because if you think somebody imagining a
Actually,
robot cleaning, everybody in the beginning will think it's a big thing. It's like before Roomba came, robot
Okay.
means a big thing.
Yeah, that makes sense.
Then dimension definition is important to know. Then you can imagine what sensors will fit in, because if you have dimension clarity, then you know what kind of sensors I can fit in.
Hmm. So what you mean is that we can also define like shape.
I think
We can like shape and dimension could be one,
Yeah, shape and dimension. Yeah.
and so for that we would have different concepts as well. So um, like I think we should avoid looking at this because this creates so much bias, so we always tend to think in this because it's also very interesting that Shubhashish mentioned, like before Roomba probably the cleaning robots were very huge, so uh, they had probably a different bias in their mind at that point.
Because they were having these legged robots, but if you think, let's say before this imagined Roomba, the normal vacuum cleaner would be somebody will be walking with this stick and vacuuming the house. Now if you have a robotic system, you think first thing you will think, okay, you will this robot will hold a vacuum thing in his hand and like moving around the house. This would be the first thinking which will come. They won't even imagine that the vacuum itself will move, so they will imagine robot moving the vacuum. So
Yeah,
so that's
yeah.
where the thought process will start. Then you think, okay, now like let's go for the next step. For example, autonomous driving, people begin thinking, okay, somebody will definitely automatically steering the wheel. Like, because if you think autonomous cars, the wheel is rotating. But if you really have an autonomous car, you don't need the steering.
Yeah, exactly. Like for
So
fully
so
autonomous car.
yeah, so fully autonomous, you don't need a steering wheel. But even today they have all those things, right? Brake pedal is there, it is going up and down. So all the things are designed that manual and automated. But so this is also the same thing they might have thought in the beginning. Okay,
Hmm.
somebody will be moving the vacuum, right? So they will not think vacuum itself is the robot.
Yeah.
So yeah, I mean that must be the thought process in the beginning from this shape and dimension concept.
Hmm. Hmm. Hmm.
And they
So.
thought, yeah, it's not possible to have such a big thing, so we'll have to go to a small thing. So then they go for small. How do you design a small thing?
Hmm.
And
Hmm. Hmm.
then circular, rectangular, box, whatever. So all kind of concepts.
Yeah. So here we can probably draw some of the uh, possible shapes. So it could very well be so currently it's kind of it's circular and it a bit cylindrical. This is one particular concept. but at the same time it could be, I mean, actually it's a good question. So why is it not circular? It's something we can also, why is it not, for example, square? Although it does make sense that it, it can rotate, and it would be the because of the radius it can, I don't know how to explain, but because of the radius, it's kind of uniform in all directions, right? So probably that's an advantage of having a circular base instead of a square.
That is right, but if you think it's a head mode, it's not a headless system. So if you have a
Hmm.
head mode system where basically it's only capable of one direction, then, for example, you are only considering the front part, not the back part, because when it's navigating, it's only thinking about the front side. Like the bumpers are also on the front, not at the back,
Hmm. Yeah,
right?
yeah,
So the circular part is only helpful in the rotation thing. It's more easy to rotate,
yeah.
right? Because it knows if the front is clear, if I rotate, I will also have the same clearance for me.
Hmm.
But if I have a rectangular at the back, then I don't know if my backside will fit in the same space where I see the front. So that is the only advantage. But for the navigation, this back circle thing is not really like advantages if it's only a head mode, so only one direction navigation.
Hmm. Yeah, that makes sense. Like the primary advantage would be its rotation, and also from a space point of view, right? So the
Yeah, right.
circle would occupy less space than a square or rectangle there.
Yeah. I mean, I think if it was a semicircle, it would be the same thing. It's not going to have affect anyway. It's a circle or semicircle. It's for this particular robot, it would be the same thing. You can think actually how it does navigation. If it would be a semicircle, it would have no problem with anything at all. The thing I think maybe with the circle thing, the benefit is the center of mass shifts to the back, so then it can use it for this staircase detection, because then center of gravity is behind, and then it has this infrared sensor in the front, so it detects the staircase before it falls. So that is where this advantage is coming up from this backside circular as well.
Hmm. 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 Yeah, and actually, like a lot of not not cleaning robots, but a lot of these small robots are also kind of semicircular, right, with two caster wheels, for example.
Yeah, right. Yeah.
Yeah. So semicircular is one particular concept. Now, again, I think this is also a bit biased because we're kind of thinking thinking from this perspective, but what are the what are like totally different shapes? It could even be for example, it we are also like in all the three concepts we are assuming that its height is way less than its the other dimensions, width and so on, but it could very well be although we would have to justify this thing as well. It could very well be that the width is lesser than the height as well, to some extent, although like from center of gravity point of view these make sense, but again we are writing all the concepts here.
So another thing, as I said, like Chandandeep, it would be nice if we are getting more general and thinking about the general product. It would be nice to imagine what can Roomba not do, which normal vacuum cleaners can do. So where are the limitations of Roomba? And then if you think, let's say, if we want to automate those things which Roomba cannot do today,
Yeah.
what kind of robotic system we will need to have to really accomplish all this task? Because Roomba has a lot of limitation, right?
Yeah,
In
actually
terms of
this
vacuuming.
is this is also an interesting point, but I think it makes sense that we discuss it after reverse engineering. So like building so once we know the whole system, like we what's inside it and everything, what are the slam features and so on, so then we can like limitations of Roomba and further improvements we can say. And then after that, like probably someone would build a startup against Roomba. So limitations of Roomba and you know addition additional features to Roomba. So this is, yeah, we can also, this is also very interesting. Okay, so moving back to shapes, I guess like this is enough for now. Does anyone want to add some different kind of shape? This is also like very limited. We have probably not thought a lot about the different kinds of concepts that could be generated. So if not, then let's go to the next part, which is, sorry, so someone mentioned an additional feature, right? I forgot which feature was mentioned. Can someone repeat?
Segregation, right? Dirt
Segregation.
segregation,
Yeah,
somebody.
yeah, yeah, yeah. Okay. Segregation of dirt. I think like this could be something to consider as additional features of this thing. Segregation of waste. So do you mean like? Do you mean by the inside the robotic system, or it goes to another system and then that segregates it?
Who raised this point?
Okay. Anyway, I think he meant like segregation of waste in somehow inside the robot.
Yes.
Although
No, uh, I mean, yeah, it can do that also.
no, but like, what did you mean by that? Going to a separate location and like,
Yes, yes. But detecting what type of that, I think that is very
if it is like going
that.
to, sorry.
Sorry, you were saying?
No, I was saying if it is going to like, do you mean there are, for example, separate bins and then it goes there and it also segregates it? Then that would require somehow an internal way of
Correct.
identifying the waste, right?
Yes, yes, yes.
I
Hmm.
think in this case, the segregation could be something like in terms of the size. Like, is it a fine particle or a medium size particle or a large size particle? Depending on that, you could segregate. That is like possible.
Yeah,
Um,
that would
so
be,
then,
yeah, probably that is like simpler. Yeah.
yeah, simpler. So you can actually have filtering system which filters different sizes at each stage.
Hmm, hmm, hmm. Yeah. So yeah, for additional features in detail, we can talk about, we cover after we cover Roomba. Yeah, and collision avoidance system. So we can write different possibilities of avoiding collisions here. So collision avoidance system.
So this could be contact based avoidance system, non-contact based.
A contact, actually,
This is
Contact based is the bumping system. Non-contact is infrared or laser or camera.
yeah, and actually I think, yeah. So Roomba has probably non-contact based, right?
No, both.
Actually,
It
both.
has a
Actually,
bumper.
both.
It
Yeah,
has
you're
both.
right.
It
It
has
has
both.
both.
For very like close objects, it has the bumper. So bumper
Hmm.
is like the definite thing which it will always use.
Hmm.
And infrared it uses before, like for both contact avoidance and also mapping.
Hmm.
But nowadays they have cameras, so they can use cameras for also knowing how to drive and where is the object or free space.
Hmm. Hmm.
So even from single camera today using deep learning, you can know exactly do path planning.
Yeah, so maybe I can divide it in camera based, non contact based, and infrared based.
And laser based, ultrasonic based. So these are the three possible contact: laser, ultrasonic.
Okay. All right, and contact based for contact based also, like this is the sensor on the bumper, but like I think this is too specific, right? Because at this stage
Not
they
bumper,
don't
it's a
know
bumping
the.
system. So bumping system, it means like it touches and then it feels like something is there. So
So a
it
button is
and
pressed, like when it presses, so a button or a switch is pressed inside, right? Do you mean that, or?
no, in a bumper, how Roomba works is basically it's a different concept. So again, it has a proximity sensor inside. So when the bumper touches, then the proximity decreases. It knows, okay, this thing
Ah,
touched
okay.
something.
So like there are two things that we can. One is proximity sensor based, and the other would be the one that I mentioned. Like it actually. So, for example, this particular bumper, when it is pressed, maybe hit from the side, then there are two or three buttons inside, and those buttons also get pressed. So that's how it knows from where it is hit.
I mean, there are multiple ways, like not just this way. There could be pneumatic sensors, like
Yeah.
pressure-based sensors. This thing is like the important thing is not the behind thing. It's more about the bumping thing because
Mm-hmm.
contact means something should be there where you hit. So
Yeah.
that thing, then after it hit, what happens? This is like another thing. There could be multiple way you detect that hit.
Hmm.
So they can detect using change of pressure, change of like this using some infrared again sensor inside, or like buttons as you said. So there could be a lot of
Hmm.
different
Yeah,
ways
there could
inside of
be
it.
like lots of different things, and even in all these things, there are like way more possibilities. But yeah, let's cover only the main one. So I think proximity would be an important one. Switch, of course, we can also
No, I
consider.
think in contact base you should definitely mention a bumping mechanism, which is very important. Like you, because this is like what causes the contact.
So bumping mechanism is like so isn't it the system that you define, isn't it like isn't it already covered in the proximity sensor based
No,
thing, or?
proximity sensors basically means something close come to a particular distance, then it fires up. But then
Yeah,
it's not really contact based.
actually, yeah.
Proximity could be non.
So actually this is like I've written it in the wrong place here then.
No, no, this is correct. This is what is used in the behind of the bumper.
No, but then it's is it it's not in contact based, right?
Yeah, that's what I'm telling. I am telling our goal here should be written that you should have a physical bumping mechanism. So it's touching something. That is the concept.
Okay.
But then
Okay.
behind how you use it, that's where you come with this button based, proximity based. This is behind.
Ah,
But
okay,
important is
I
there
get
should
it.
be a contact surface. So
Hmm.
the robot
Hmm,
should
hmm.
have a contact point where it should touch and feel. And
Yeah.
then you can define, will it have it 360-degree or completely around or only on the front part or only on the side part. So then you should decide where will be the contact part. Will it be only in certain area or the 360-degree?
Hmm. Hmm.
Because Roomba only has half of it, right?
Yeah, yeah, yeah. I get it. So like, there are two aspects of this, like external and internal, right? So external would be the bumping system that you mentioned.
Yeah, exactly. That's what I mean. The internal is not the important for the customer. Outside is more important, like how it really detects the objects.
Hmm. External is bumping system, and then this internal could be these things.
Yeah, this is internal, exactly.
Okay. All right. So obstacle avoidance and safety of the robot, safety of the humans, storing the waste. So storing of the waste. Let's cover first storing of the waste. I don't know if my writing is clear enough, but we are also speaking. So storing the waste. So like here we would not try to think of the shapes and sizes of compartments. So one would actually be a compartment based system, and then we can write other different ways of storing it. So this compartment based system is, we are assuming like it could be a solid box, or maybe it could be a pouch or something.
Yeah, right.
Compartment
Yeah.
based, and then it would be a pouch type way of storing. How else could it be stored?
So then another concept would be storing and also removal, right? So how would you take out the dust?
Hmm.
This is also important point. Like if you have a pouch, will you replace it or will it auto empty or how will it happen? Like this whole because
Yeah,
vacuum cleaner has both systems, right? If you can reuse the compartment or you can throw out.
removing the waste is another functional requirement, because yeah, this is important as well.
The waste is manual mode. Like we will empty the compartment and then clean the. I think even there is filter in the compartment. We have to even clean that manually, and then we will install the compartment after cleaning it in the robot.
Hmm. In the actual Roomba, right?
Yeah, I don't know about Roomba, but I know about other robots such as MI robot. I know it's
Okay.
specific. Yeah,
Hmm, hmm, hmm.
but generally, uh, I think it's done that only. Yeah.
Yeah, so in Roomba, I think it's also the same.
So there's a water tank there's a water tank inside the small water tank uh, for mopping purpose, where it will wet the mop and then it will mop the floor.
Hmm.
Surface. Yes.
So, so the what we are targeting now is just dry waste. So the resources that I referred to, it was there was no water based system or anything in Roomba. Does anyone know if this feature of actually mobbing is also there in Roomba? I don't think so.
Roomba has one series which is
No.
also doing mopping.
Out,
It's
so
actually
okay. So one particular
so it has
variant.
so it has a Saug and Wish robot. It's combo. There is like a combo robot.
Okay.
It's it's two in one design. So it's also doing the vacuuming and also it's wish. It's not really dry wet mopping. I think it's only dry. I think it's only doing
Okay. Okay.
dry mopping.
Hmm.
It's like brushes. It has brushes, so it's like kind of doing the mopping with the dry thing. But I think wet mopping is still not there. So they are designed like only dry things, no liquid.
Yeah. And yeah, so the water feature, someone mentioned, which robot was it? Apurv, did you mention?
MI robot
MI
for
robot? Yeah,
vacuum.
okay. Hmm. Okay.
Butter is like very like complicated thing because then you have to also think how it is protected, the electronic circuits and everything. It's
Hmm.
There's a
very like
water pump motor inside it.
yeah, it's like very complicated process.
Yeah.
Water should be below and then electronics should be on the top.
Hmm. Yeah, that would like if we targeted water, then our there would be addition in our functional requirements as well.
Uh,
So
So
storing the
I
waste.
had something to say.
Yeah. Go ahead.
I was saying, what if we kept one robot just for watering and another one for mopping? So like it's a chain of two robots.
So in the current system,
In the current system, it is one, I guess. It's not two.
The current
no,
system doesn't have any water
no,
system.
no,
It's
not
not having.
so by current system, I just mean like what we are doing right now. You mean to include this in this, or
To include for in this, or it could be made since we are reverse engineering. You could add a new component as well. Or,
yeah? So like again, this could be added to additional features. Maybe I'll write down here so we don't miss out on some. So like water mopping thing, another would be segregation, right? Segregation. So these two additional features that we can consider as well. And what else are we left in the functional requirements? So storing the waste, and then removing the waste. This is also, let's quickly define these.
Storing, I think you wrote right somewhere.
Storing, yeah, I have written. So now removing the waste. So storing waste is like compartment type and pouch type is just two I have mentioned right now.
So removal again will depend on the storing. Like if you have compartment,
Yeah.
then it's a manual removal and then like taking out, and it's a reusable compartment. But if you have this pouch thing, then it's of course needs to be replaced.
Hmm. So I think like removing, we can just waste like so yeah, it actually for storing the waste, we should write fixed compartment or replaceable. So for example, I think pouch is also kind of it's permanent, right? And we don't really need to change it very often unless it tears off or something.
Yeah, but how will you remove the waste from the pouch? So pouch again, it's like what kind of pouch you mean?
Yeah, yeah. So yeah, depends on the type of pouch as well. So here I guess like okay, let's then define pouch in removable compartment, and here in permanent. So I'm just like vaguely writing this thing. So like permanent would be a compartment type. So this would always this would never be replaced. Or pouch, we are assuming that it is a replaceable kind of pouch, so we have to throw it every time, right? Of course there can be multiple concepts in both of these things. Yeah, and now removing the waste would depend on whether it's a permanent type of thing or
So I think there is nothing called permanent. It's more about reusable because you don't know what is permanent.
Mhm.
So it's more about reusable or replaceable. Because
Reusable or
reusable,
yeah.
if you have reusable, then okay, you can empty it again, reuse it.
Okay. Yeah, sure. Reusable and replaceable, and if it is reusable, then yeah. So another, I think there are probably three things here we can write. So uh, I think one additional thing is automatic disposal of waste. Automatic disposal. Maybe this is this could be an additional feature to consider, not in this. Right. So automatic waste disposal, and this is like also vague at this point.
Mm.
And removing waste, so when it's reusable, so in so here in removing waste we are only considering the manual ways of removing. When it's reusable,
Yeah,
then yeah, we just throw it and then we put it back. So
yeah.
disassembling it and reassembling it, I should just write it.
Yeah, because this is how Roomba works. In Roomba, you remove the compartment, throw out the waste, and put it back.
Yeah. And replaceable means we just throw it and have a new pouch. Throw
Yeah,
and new
just replace a couch. Yeah, throw and
replace, right?
replace.
The pouch. Although, yeah, I mean, even in vacuum cleaners, the pouch, depends actually. Maybe you can just empty the pouch and reuse it again as well, right?
Yeah, but mostly vacuum cleaner pouches you never empty it. You always throw it and you put it new back.
But
Only
like,
thing which is
if it is a pouch made of cloth and it can be emptied as well.
yeah, yeah, that's right. But normally in vacuum cleaners you don't have this kind of concept. Pouches
Hmm.
are always replaced.
Okay.
Never have concept where pouch is reusable. So
Hmm.
the reusable things are mostly compartment, glass compartment or metal compartments. So these are like taken out, thrown, and then reused. But then the pouch are mostly because they get also dirty. They have
Yeah.
mostly pouch also has kind of a filtering system.
Hmm, hmm,
So
hmm,
what
hmm.
really happens is the even if you throw it, still the pouch will be filled with dust inside. So you can't really reuse it.
Yeah, that makes sense. Yeah, they also have their filtering system. Yeah, you're right.
That's why it's not that easy to reuse pouch.
Hmm.
The pouches are very cheap. But then this was also a business model, this pouch thing, because then they
Hmm.
thought, okay, we'll sell the vacuum cleaner cheap, but then we'll earn money on pouch.
Ah, okay. Was it like
It's like
actual?
it's like razor and blade business model. So basically, you keep the razor very low cost, but the blades will be expensive.
Ah, interesting.
Normally, this was the business model for vacuum cleaners at the beginning. So they gave vacuum cleaners very cheap, but then the pouch will be expensive.
And like, yeah, you have to replace the pouch. So, yeah, that's interesting.
Exactly. That's the problem.
So, safety of the robot. So, for safety of the robot, we will be considering that the robot does not damage and it can damage when it falls from a height. So, like, there's different criteria. So, safety against height, I can write safety against height and also probably like safety from collisions, I guess, right? These two things, safety from collisions and also maybe uh, some water or something spills on it, safety against
Inclination can also be taken. It's not accident.
inclination and height, I think. Yeah, you're right. So here, and safety against uh, liquid or other things as well. Yeah, we can add like more things here as well. uh, but let's now quickly wind off with this so we can go to the main features and discuss the actual Roomba features now. So safety against height and inclination. So like having a sensor that gives it information when when there's no ground in front or of it, or when it is inclined. So some kind of detection systems detecting.
For height, we can use proximity. For the inclination, we can use a GPU, IMU, sorry, an IMU.
Mhm. Yeah, so proximity sensors could be used. Even a laser could be projected on the ground or something, or an infrared sensor, proximity based, infrared based. I don't think I would be able to read my own thing after this. Yeah, Okay, anyway, I'm trying to like wind off with this thing because we still haven't started with the main part. Proximity based, infrared based, maybe it uses IMU sensors. How do you want to? Yeah, okay, uh, probably, yeah, IMU sensor based. And okay, safety from collisions
But I'm
again.
concerned the fact where if it gains height somehow, how will it go back?
Sorry.
I mean, suppose like there is a very small inclination of 5-10 degrees, and the robot detects it, then how will it go back?
So that's again like specifics of this system. So right now we don't even know which one is which of the sensors or system type would be used. But this is once we maybe decide that okay, it's maybe we are using proximity sensors. Then we will have to define a way as well that uh, how does it avoid going to that, or how does it bounce back or something, right? Okay, so safety from collisions could be, we can use infrared sensors, and then safety against liquid. This would be interesting, maybe having a like protecting the components against water, main protecting only the important electronic components against it, because maybe the, yeah, plastic wouldn't matter, right? Components against it, and then it another could be protecting the outer surface so it doesn't even go inside. This could be right. And for safety of the human again.
So the speed of the robot should be limited.
Hmm.
Speed limit on robot speed. Sorry, speed limit on the robot. Then no moving objects um, in the touchable range, like contact range.
Speed limit, con- uh, contact range, so maybe it range
That's
set, yeah.
contact range and no moving objects in that, like no sharp areas. That's another thing.
Yeah, so this would be like the more mechanical exterior design, sharp
Yeah.
edges and stuff. And it should also uh, stop when it so this would be the same in contact range, right? It should stop if it detects that someone is holding it or someone is coming close to it.
Yeah, if you flip it other direction, it should not be like it should not turn on. So it should have a sensor to detect if it's rightly positioned, then it
Hmm.
should turn on the motors.
Yeah. Okay, so we have vaguely considered different kinds of possibilities. Now let's come to the main Roomba part. So reverse engineering Roomba. Yes. Okay, so like feel free to, yeah, tell me what you
What
know already about Roomba. So let's try to make it. So this is a Roomba. Here we have this bumper system that we also already talked about, and I think we have one infrared sensor, and we have two sort of switches. Now I might have uh, just checked one particular model of it. So uh, Feel free to tell me if there are not a lot of features that I've covered or some features that I missed or something. So these are like the switches, and this is infrared sensor. This is called bumper, right? Or how is it called in
Yeah,
Roomba?
yeah, it's called bumper. Yeah, yeah, it's called bumper.
Okay. And here, like we can also see, there's a power button here. So
We need wheel sensors,
sorry,
sensors for the wheel. I mean, the angular
encoders,
position of, yes,
encoder.
encoders.
Yeah. Yeah. So we have, I think, three wheels in this, and they are these two wheels are not connected.
And one caster wheel,
Yeah.
which is,
This one is
yeah,
the caster wheel.
and uh, two motors, that is two for two wheels. Yeah.
Yeah, exactly. So these are, I think, DC brushless motor, or which motor did they use? I wrote down some of the points, but I haven't written everything. DC brushed motor they used. So DC brushed motors, and like, okay, so now this is like we are let's try to just label what comes to our mind, and then we'll go to our functional requirements and compare our compare what the functional requirements are with how they have solved it, and maybe what they thought about it. Yeah, so I think there are more sensors here. There's a piezoelectric sensor that listens to noise and actually uh, just detects where dust. It's kind of like a dirt detector. So one piezoelectric sensor, right? And there are also these collision sensors. So let me just go through this. Rubber rollers. So this is for the vacuum based cleaning. I think if we go to the bottom side of it, then we have these so called rubber rollers. Right, as it moves, these rollers actually assist in pulling the dust from the ground, and I think it's also then connected to the vacuum system. So rubber rollers, piezoelectric sensor is done. Then a washable bin, just a normal bin they are using for storage, and then a side brush. So there's also a side brush. I don't know the exact location and where it is, but I'll just draw it kind of here. So we have a side brush that is the actual use of it is that it can take it from corners or some around the walls, some of the dust there. What else? Side brush. Then this battery. We have this battery kind of system. Then docking, charging contacts. So there's one like washable compartment I should write first. Washable compartment. Then a battery. Again, I think the location, I would probably need your help if someone knows the exact location, but it actually doesn't matter since we are just making it roughly. Battery arrangement, and then we have an external docking system which I'll just draw like this, right? And in the docking system also we have these uh, infrared actually infrared projectors, or how is it called? The mouse sensor. Then yeah, I don't think I've written it, but it's actually essentially projects these uh, two infrared lasers, do we call, or I don't know how do we call it. So it projects to the infrared rays, and then it is detected by the infrared sensors on the robot, something like that, right? Yeah, before I write more, I should now ask you at this point, is there anything that is wrong here, or anything that is probably different in another variant, or anything you want to add?
What is this infrared? I didn't understand. Where did you place it?
Which one?
Infrared
This,
module?
okay. So this is this, okay. I wrote it two times. So infrared sensors, now I've already added it. So I don't know exactly if there was just one sensor for these two rays, but there were probably two, right? Two infrared
There were two
sensors.
both sides. There will be infrared on both sides and also on the bottom side for the staircase detection.
Yeah, also on the bottom side. Okay. So I don't know the
Total there
location.
are
Where
three.
exactly is it located? At the bottom, so I'll write it in.
I sent a video. If you look there, you'll see how it is placed, the sensors, in the
Okay.
chat section. So it
Mm-hmm.
shows there are two infrared like emitters and receivers, and bottom side two again like totally.
Yeah, I also shared this particular video. This is like really actual breakdown. It's 21 minutes or so long. So I
The bottom
recommend
one is a small one which I sent. It's a
this
very
one.
small video. Yeah,
Okay, let's go for.
it's like the sensor only like 4 minutes, but
Leave the
you can go
deconstruction to
Ah, yeah,
us.
I've seen this
We
one.
have vacuums going.
go
The cleaner
forward. It
follows
shows you
no
the sensor.
preset
Yeah,
path.
Does
it shows.
anyone know, like, is this is an episode by Discovery Science, right? Deconstructed. So, does anyone have like full episode of this? Because this is just 4 minutes.
Circuit.
But then
That
here you
circuit
already see
contains
the
a voltmeter
sensors.
uses
Yeah,
Yeah, so
like generally
It might
asking.
be available on Discovery
when
Plus.
the robot hits an
Just check.
object. The bumper
Okay.
backs up and presses on the sensors.
So
so yeah,
these
these are
The
the
sensors
two,
send a signal to the printed circuit.
this is the
the
chip.
these are like these two ones are what I've labeled actually as switches. So this,
These are proximity switches which are used for the bumper. Then below that you have the
yeah,
infrared
The
sensor. So
sensors
go
send a
forward, you
signal
will
to the
see the
printed
infrared
circuit.
sensor.
yeah,
Afterwards, it will show you the emitter and
If
the
both
receiver.
sensors are if the sensors turns and changes direction. Well, that
Now
tells
it's
the
showing.
robot it's hit an object on the side.
Yeah, now it's infrared.
If the sensors are triggered one after the other, the robot
This
knows
is
it's
bumper.
stuck in a
Yeah, this
corner.
is like
So
they
it
have two
turns and
bumpers,
changes
so
direction.
it knows it is hitting left, right, or it hit
Impressive.
something in the front. Because if it
And
hit front,
there's
then both
more.
sensors will be
The
triggered.
robot's
If
infrared
it
light
hit the
sensors.
side, it will
The
only trigger
invisible
one
light the
sensor.
robot uses.
yeah. So actually, like in the diagram that I've labeled, in the bumping system, you are calling these two like sort of buttons that are being pressed after it is rotated as
No, no, no. These are not
bumpers.
buttons. These are proximity sensors. So basically, when you press it, it goes near that sensor, so it detects, okay, it came close, it means it's pressed.
Ah,
So
okay,
it's
okay. So
non-contact.
it's okay. So then I labeled it actually wrong there. I wrote it as switches. So these are actually proximity sensors, right?
Yeah, is proximity. Proximity is better because then it's no mechanical contact, so it's better.
Yeah, makes sense.
Because
Yeah.
switches will be problem, because if you think, sometimes if you switch press in one particular way, it will press better, the other way it will not press better, so it's like non reliable.
Hmm, hmm, hmm. And like
So
mechanical, so yeah, there's like you also have to have good tolerance, so it presses actually.
exactly, so this is like risky thing. If it presses very slow, then you don't know. If it presses hard, then maybe the switch will press or not. So this again you have to calibrate, and all, it's very complicated. But if
Okay.
proximity, it will only work when the the distance will decrease, so it knows, okay, it came close.
Hmm, hmm, hmm. Yeah.
And there's
Go
one
forward,
knows
then
at
you will
what
see
distance to travel.
the infrared sensor.
So this is like it's just one infrared sensor, right?
Along
Yeah,
with
the
the
other
field
side
of
also
view.
they have. So it's
Three
having
sensors
a
at the
Ah,
bottom
emitter
okay.
and a
Yeah.
the
detector.
robot can detect
So
any
on two
stairs,
sides we have the.
and a sensor on top
Yeah,
that keeps the robot from
and this is
going
the
where it's
top
not
one to
supposed to
detect like
go.
this boundary
To
thing,
get a
like.
handle on how
But this
this
is a
works,
different thing.
it's
Now
time
you
to
will
have a
see they
look
will
inside.
take out the sensors. Yeah, this is,
The side
yeah.
sensor
Now
is
they
made up
figured
of
out
a
exactly how it
receiver
is.
Hmm.
So here you have the emitter, infrared emitter,
and an
Hmm.
emitter.
and
The
here
emitter contains a
okay, no, this
diode
was the
which
detector. This
emits
is the emitter.
infrared
Yeah, this
beams,
emits the light,
invisible light which bounces
and
off
then it
walls.
detects after it reflects.
The emitter is positioned so the infrared beams
Yeah,
always hit the wall
Yeah.
at a
this is
specific
how.
angle. When the robot is at the ideal distance from the wall, 2/10 of an inch, the infrared beams bounce directly back to the receiver. If the infrared and the robot
Okay.
install a receiver, the emitter is in a the robot reaches this border, it knows what's off limits
Okay.
before.
Then yeah, I think we got what we wanted from here. Yes. So what I'm missing here is probably an emitter receiver system, right? So like one thing I think I missed somewhere. There's probably an infrared detector for the docking station as well, right? Yeah, in the center, I mean. So we definitely know that there are these two emitters on the side and the receiver. Subhashish, where in the video was it? Was it at the
The
side,
receiver is on the left side.
like
So
here,
and the
sort of?
transmitter, yeah, receiver was there. Transmitter was on the right side. No, not right means not there. Just on the right of that same thing. So just side of each other.
Ah, okay,
The
here,
two were
like
placed.
here.
Yeah,
Okay.
this is the transmitter, and then there was the, no, not there. No, no, there were two sets. One, two on the left, two on the right. So you can imagine a triangle
Ah, okay.
where you placed it.
What you mean
Yeah,
is like there are two emitters on one side and two receivers on one side, or
exactly, exactly.
okay,
So it
okay.
just reflects from there itself. So it will detect independently left side, right side. So they have no relation with each other.
Yeah, yeah, yeah. Yeah, that is even more logical, right?
So the light will come out and then go back there itself in the same place.
So I'll just write these emitters here.
Exactly, yeah. Emitter and also the detector. No, no, no. On each side, one emitter, one detector.
Oh, okay. Then I understood
Yeah,
wrong. So then initial diagram was correct, right?
yeah. So initial diagram you said only the infrared, but then it has sets of emitter and receiver.
Okay, okay. Yeah, yeah. Sorry. emitter and receiver, and the same for the other
Same
side.
thing on the other side, yeah. And then the same thing also on the bottom side. So basically three sets.
Hmm. Hmm.
On the front side, bottom front, not in the middle. It's in the front because the center of gravity is in the middle, so it has to detect before it falls.
Yeah.
So it is exactly on the front side, very front,
Yeah, and this one
like a
is
bill.
for avoiding falling of the robot.
Yeah, exactly. So the detection should happen before the robot's weight is on the front. So basically the weight is at the back and detection happens, and then it doesn't move forward.
Hmm. Hmm. Hmm.
So the
Yes. And yeah, regarding this, I think there's also one infrared sensor here, right, for
yeah, that's right,
to
right.
detect the, like, when it reaches the docking station. And on one of the videos, I saw that it kind of aligns itself with these two infrared beams, and it kind of first goes to left and then right, and like centers itself slowly. I think I definitely missed some of the system. So yeah, okay, wheels, of course. So there's this yeah, DC brushed motors, and then there's also magnetic encoders on the wheels, and that is just sort of like a speedometer, or that would give us how fast the Roomba is moving. So this is done. Is a micro switch, which tells us that wheels have left contact from the ground. Safety feature. Okay, so yeah, this micro switch is actually like, if we take this particular wheel into account, so this wheel has sort of a switch, and the switch is always pressed when it is on the ground. I don't know exactly where it is located, but like somewhere around this wheel assembly. So it's always pressed, and when someone picks it, then this is not pressed, so it knows that, yeah, it's in the air, so it stops spinning. So
Uh,
this is
Actually,
another thing.
the best way to design this system is if you can um, if you can have this wheel pressing onto like when you put it. So basically, you combine two things like wheel plus also the proximity sensor. So you can have a proximity in the middle,
Hmm.
and then you also have the wheel pressed. So basically, when the wheel will press, also it will detect, like let's say like same as a bumping mechanism. So it knows it's on staying on the ground.
Yeah.
Then plus additionally, you have the proximity sensor in the middle to know, okay, it's actually having a distance of this much from the floor. If you combine
Uh-huh.
these two, then it's very safe mechanism. Only one thing is actually not safe because then somebody can pick up and press that thing and then it starts moving.
Yeah, yeah, yeah.
Then it's actually dangerous. So the
But
wheel should
actually,
only
like,
move when that wheel is pressed.
actually, even the proximity thing can be exploited, right? If someone presses it and also maybe keeps his hand or something there,
Yeah,
so
but if you combine this, like if you combine the wheel being pressed and proximity, then it's difficult because
yeah,
it's very hard because then you have to press both wheels and then you have to also use the proximity. It's not easy to do that.
yeah, definitely, it makes it more difficult.
Yeah, so that's why it's more solid, actually, a better design.
But they don't have it, right? Currently, they
They
don't
don't
have a
have it, but it's
proximity
better
in the.
design. They don't have it.
Yeah. Okay. So let's see. I'm sure I missed some of the, yeah, features here. So magnetic encoder is done. Electric discharge. Yeah, this is more. This was more related to kind of pulling the dust or something, not a very specific one. So, and micro switch we have covered. So the wheels have suspension system as well. You don't need to go deeper into that. DC brushed motor, two wheel drives independently, total three wheels. Then a mobility system, yeah, two wheels and one caster. Then we also have an optical mouse sensor. Uh, yeah, that tells it where it is heading. I don't know where exactly it is placed, but it's kind of like projecting laser. So laser sensor is probably what we can say. So somewhere around here, I guess. Laser sensor that projects a laser, like kind of the bottom side of an optical mouse. and we have 4 front cliff sensors and 2 back cliff sensors. So the cliff sensors is just these these infrared sensors that prevent it from falling, basically.
Uh,
There are just total of 4 front and 2 cliff sensors, and then cliff sensor optical sensors that detect the lack of, yeah, okay, the same thing you have described. And signal no longer reflected from robot comes back to, yeah, okay. And yeah, this is the thing that I was talking about. This they call it as binoculars, and there are 2 emitters. Yeah, emitters was the word I was looking for actually here. So these are infrared emitters, and these produce 2 beams of light, and then these are detected. And there's also, this is also interesting, there's a halo, invisible circle of light around the dock, and it prevents the robot from accidentally bumping into the dock. So there's kind of uh, some area defined here, and it prevents the robot from actually bumping into this thing again and again. And this particular system,
Yeah, that is
this
the sensor which is on the top of it. So this is what detects the docking system. So basically on the top, you see in the
sensor
head, there is a small, on the
on
head,
top.
middle. Yeah,
And
this one.
this
This,
is the power button,
not
right?
there,
Ah,
in
okay,
the
here.
front.
Yeah.
Yeah. This thing detects the boundary which you were talking about, the docking station boundary.
Ah,
So
yeah,
this
yeah, yeah.
particular, that is a sensor used for that.
Okay, all right. Yeah. Mhm. And what else? So just to mention this, that this particular system is called Roomba room confinement, and it just linking of Roomba and dock. And there is this metal contacts that meet with the contacts on the dock. So this is another thing: charging docks, dock battery, and then bottom protective cover for battery and electronics, side brush, washable bin, piezoelectric sensor. Yeah, okay. So I have covered everything. There might still be some things that I'm missing, because it's just like um probably one variant. I'm not aware of the different variants and differences in features there that we have. Okay,
I also
so
shared a video of this 980 where the camera system is there. So in the chat room. So
the one
there
with
you
camera,
see.
yeah. So the one that I watched, I think, so there was no camera system there. So yeah,
That's one
let's
of the
also
camera.
then include the camera system.
This is the new Roomba 980, and it's the first iRobot vacuum with a built-in camera. But this camera isn't creepily capturing video in your home.
Your
It's
sound
used to
is
map
not
out a floor plan
getting shared.
as the Roomba cleans.
Okay, let me then stream application again. Do we have sound now?
Because of the camera, this Roomba can travel in rows of straight
Yeah.
lines instead of just zigging and zagging randomly as older iRobot vacs did. It's also the first Roomba to connect to the internet via Wi-Fi, allowing you to command it with a smartphone, even if you're not at home. Click the clean button on the app and drive it around manually the way you can Nito's new Wi-Fi equipped bot vac connected. When you're not driving it, the bot vac can map its way around the house too.
Actually, here it's like it's squarish, right? This
No,
arrangement
both is there. There is both options. No, it's not squarish. It is round at the
on
front and
at
back
the
side.
front. Okay, yeah, yeah.
Yeah. But they also have a Roomba now, which is also
This is
rectangular.
circle.
So
Okay.
yeah.
So like, is this are these different kinds of features on different? Why do we have like one square and one
So
circle?
the square is easier for the docking mechanism.
Ah,
The
yeah.
backside square is easy to because it docks at the square side, not at the round side. So the square side is the docking side, and the front is the bumping side, where the it's always better to have the round circular bumping. But of course, Rectangular is not so good for bumping mechanism. That's the problem.
Yeah, yeah. But then, like for docking in circular, then the circular portion goes. So this would be the portion, right? For docking.
Yeah, this is the
Hmm.
this one is having the docking at the other side. And this is building the map with the camera also.
Yeah. So
This is the leader, the laser sensor. They have a camera and laser also in the 980.
and then they do sensor fusion.
It's a V slam, visual slam.
Yeah, but they also include the laser scan there, right?
Yeah, right. Yeah,
So they probably do then sensor fusion and then do slam, right? Or
yeah, right. Yeah.
Roomba. Okay, like should I pause at a specific instant where they tell more about the camera? Around here, I guess, right?
Its way around
Yeah,
the
the
house
camera
too,
positioning,
but it
if you
uses
see,
laser.
it's in like in the front frost, it showed in the beginning where the camera is. This is the laser sensor, but in the beginning it showed the camera.
Yeah.
Yeah, somewhere in the front showed where the camera is located. Yeah, that's where.
New Roomba 980, and it's the first iRobot vacuum with a built-in camera. But this camera isn't
Yeah,
creepily
this is where
capturing
the
video in
camera
your
is.
home.
I think in the middle, we build behind the power button. There is the camera. Here,
This.
yeah,
Yeah.
yeah, there is the camera. Yeah,
Okay.
It's
very
used to map
strange
out a floor
location.
plan and a
Yeah.
Roomba blink.
Yeah. I was expecting like somewhere around here or something.
Yeah, there is the camera.
Yeah, but if it's like it's elevated enough, then probably. Yeah, but I guess I don't know. It makes more logical sense that it's in the front, right? So it can.
Yeah, exactly. Maybe I don't know why they have the camera, so it's not really clear to me why they have it the back.
Yeah.
And then they
Because
have
of
the
the
laser
camera,
sensor
this
somewhere in
Roomba
the
can
middle.
travel in
So.
rows of straight lines instead of just zigging and
Laser
zagging.
sensor is somewhere in the middle.
Yeah, in the middle. If you see, go forward, it will show you the laser sensor.
Okay.
Randomly,
The
as older
rays
iRobot
coming
vacs
out.
did. It's also the first Roomba to connect to the internet via Wi-Fi, allowing you to command it with a smartphone, even if you're not at home. Click the clean button on the app or the vac itself, and the Roomba goes about its business. Unfortunately, you can't drive it
So
around
this is the side brush that I was talking
Yeah,
about.
brush. Yeah. Right.
manually the way you can Nito's new Wi-Fi equipped bot vac connected. When you're not driving it, the bot vac can map its way around the house too, but it uses lasers. In this footage
This
provided
one laser,
by iRobot,
yeah.
which you can't actually extract from the Roomba, you can see how the vac sketches out its surroundings, creating a real-time map like in a video game.
You
The
can
vac
see the
creates a-
map on the application or
Yeah, yeah,
anything.
you can access. That's what it's also telling, that you can also access the map. I think I have a link where you can. I can
map
share
and
it.
video footage 90 minutes after a cleaning mission, and the data never gets transmitted to the
Oh,
cloud
there is a
or
nice
anywhere
article
else.
actually.
So the Roomba 980 is no privacy threat, but it also can't double as a roaming home security camera. The Roomba 980 is designed to clean 2 or 3 rooms on a charge,
Wait, I
taking
will
up
send
to
in the
3
chatting
hours.
room.
It can even handle your whole house,
Okay.
or at least a floor, though it'll likely stop to recharge during the mission. The Roomba
So in the chat room you shared this Spectrum article.
Is talking about that particular thing. So it's somehow mapping different objects inside the room. So it's knowing where it is. So it's creating. Oh, okay. Now I understand. So it's using laser to create the map, and then cameras are used to locate objects in the map. So then it knows, okay, where is the sofa, where is the bed, where is what. So it is
Oh,
also
okay.
so it's mapping the object. So camera is not for navigation. Camera is, but it says VSLAM. It's written, but then I think it's building a 3D map. It's not just a 2D. So it's having all the
Almost like
objects inside.
it's almost like an iPad Pro in some
Yeah,
sense.
it's building a complete 3D map of your whole house.
Yeah.
So
Very interesting.
so
Very
that's
advanced
why they have like in the middle and not probably in the front.
in the front. Yeah, because then they can see everything from the distance.
Yeah, yeah.
Yeah,
Interesting.
it's very
So
interesting actually.
they've described it here, right? I haven't read this particular
Yeah,
article.
yeah, yeah.
Yeah, I think like we should like definitely do this one specific session for just VSlam stuff, right?
V-slam is very, I mean, normally for any robotics, V-slam and V-slam is very important to
Hmm.
even, like everybody should know that because this is the backbone of navigation.
True, true. Yeah. Okay. So here we have tried to today do, I'll just summarize what we have done and then we can finalize the next sessions, and I'll also get some feedback on whether this shitty handwriting works or not and other things regarding today's meetup. So today what we did was we defined first a problem statement that they might have considered while initially designing Roomba. By the way, is my screen visible? I think I forgot to change the screen, right?
Okay, so your presentation wasn't cleanly
Yeah,
visible.
okay. So now, yeah, so what I was saying is that we first defined the problem statement and we decided what the assumptions might have been initially, like based on iRobot's company stage at that point, and then functional requirements, what would be the requirements that this product should be solving. Then we kind of thought about overall system without trying to have a lot of biases, and ideally after this particular stage there would be concept scoring and actually deciding the concept, but we were trying to just like have roughly go through the whole process without actually building anything. So then we went on to reverse engineer it, and we kind of divided the Roomba into different components that it is made up of, and we also considered the possibility of additional features that could be added to Roomba. And yeah, after that we actually saw a vision system as well. So first of all, like I want to have some feedback on today's session and if we can make it something better, and whether this particular way of conducting meetups is better or worse than what we do normally with the PPT thing. So
I can give a suggestion.
yeah.
What we can do is we can make a Jamboard, and on that Jamboard we can give that link separately on our DMs or on the chat room, and so that everyone can jot down things which they
Ah,
like to
what's a
jot.
Jamboard actually? Like
Okay,
collaboratively?
so yeah, so it's a collaborative jotting down platform. So it's uh, like very much available on Google Meets. So when you make a Google Meet,
Jamboard?
no,
Jamboard.
it's Jamboard. It's one word. Yeah. So when you make a Google Meet, there is an automatic link generator on which you can create a Jamboard as well. So once you create that Jamboard, your Google Meet and the Jamboard both are linked together, and then the Jamboard can be saved onto your Google Drive. So it's a different file link altogether for this.
Okay. And multiple
So
people can do anything on this, right?
yeah, multiple people can do anything with this. So if you give this invite link to me, Shubhashi, Shapur, or anyone else who joins,
Okay.
they
Yeah.
all can put down their thoughts, and then you can be the moderator for this. So you can erase this as well if you want to. So
Hmm.
just to maintain, the it's clean. It's not that much written around. So
Yeah.
you can do.
That's interesting. Yeah, that's an interesting suggestion that we can implement. Okay. Yeah, thanks. Thanks for this suggestion. I'll take this into account. Yeah, so any other specific feedback like Apurv and Shubhashish, what do you think?
I think it was good, but of course the number of people somehow reduced today.
Yeah,
So
it's
I mean,
it's I'm not even now considering that because like as long as at least one or two people join, I'll just start the meeting. But
that is right.
yeah,
Yeah. The point is like what would be the reasons where like it's not able to attract more people or audience or participation? Like what could be done? These are the things which are very important because, like for example, what I think, like there was this guy, right, Atmaras. What did you talk to him? What happened? What was his feedback? Like why he did not join anymore?
yeah, I talked to him, but he's actually busy with some other his with his thesis stuff a lot these days. So that's why
Mm-hmm.
he's focusing on that. But also, I created an Eventbrite event. I've actually not been sharing it a lot, so I'll probably share it, and I'll also ask everyone if you can invite people who would be interested in this and who would like to participate in these kinds of meetings to just share with them. I know Shubhashish keeps on inviting people he knows all the time. So yeah, and also Krish also you also invite, and so anyways, like if you know people who would be interested, because like I think
Like
this is
one thing I am little wondering that you said last time there are a lot of people from India who are in robotics course in RWTH auction. So
yeah, yeah.
why does not this thing is spreaded or
Actually,
they are having their own thing?
the thing is that like last time I also invited. So the thing is like like you probably know, right? When you are doing your masters, then there's lots of different things to take into account. So like time and again, I ask some of the people, but then it's probably difficult to join regularly because of exams, and I think these days exams and everything are going on as well.
I mean, if you think like as I heard last time, you have like more than 90 people, right, already in robotics course.
70, but yeah.
So 70 people, if you think about 5 to 6 people join, even though they are not regular or somebody else comes out, like
Hmm.
then it will like create. And the best thing would be like you are already going. Many people will be doing some different projects also parallel, right, in
Yeah, yeah.
robotics. Some people, if are intensive, some are in thesis, or somebody
Hmm.
in the beginning stage at university lab course and all. You will have robotics assignments. Then this will add a lot of fun here to
Yeah.
discuss a lot of robotics thing.
Yeah, yeah, yeah.
So I was thinking like because you have that right thing there, you have contact to a lot of people who are in robotics. If I were in your place, I would have tried to see how these guys could be like brought into this platform.
Hmm. Yeah,
Many people,
it's like
yeah.
I think last time also like at least two or three people joined from my course. So yeah, it's just the thing that it's sometimes difficult because everyone has different exams and everything going on. But I try to invite all my friends and everyone I know from the course.
That's one thing. Other thing would be like how like the people themselves can also little bit you can say bring some new ideas here. The point is like people come when they get some recognition. That's one thing very important. That is one of the motivation. So if you have somebody coming in and like doing something the way you do, right, like similar thing, if some people can do here similar things, and I'm sure that there would be also people who are knowledgeable and also motivated kind of people. So this would be like very very good thing, because then it's having a multi-dimensional scaling of thing. Like if you are now trying to scale this thing up on your own, but if the same thing happens with other people, like for example, you saw I got like Paisan into this thing. I told Kunal come here. So if I know somebody, I will say come here. But then same thing if other people do on their own, then what happens is like this thing will scale in multi-direction. Like just imagine
Yeah.
why Facebook scaled up, because there was no somebody one person controlling the scaling up of Facebook. So everybody controlled. They thought like, okay, I want more my friends to come in here, so I have
Hmm.
fun. Then they said their friends to come in. The only thing it will happen is people have their own involvement here.
Hmm. Hmm. Hmm.
So in your course, if there are, I mean, see, it's a robotic platform. So basically, people who have interest in robotics and also knowledge in robotics, or computer vision and all those things, if they are kind of coming and like showing, sharing, then it will really grow.
Yeah, I agree. I agree. Actually, like I'm also not concentrating on this side too much because I'm also in the middle of my thesis. But
Yeah, right, right.
actually, yeah, it makes sense. Yeah. So uh, yeah, the thing is that yeah, I can try to invite people when they also have not a lot of exams and other stuff going on. So yeah, but like it's a
That,
good point. Like I think people are definitely interested in it. The only problem is that time is an issue many times.
so I mean, normally, like you said, you have contacts to people in, let's say, autonomous driving and all those kind of things. What happens if these people come and like also join in, like from industry also? Like if I think
Yeah.
there are very less people inside from industry coming in here, right? So that would be
Hmm.
also interesting, because if you think students also would be motivated if somebody from industry joins and like participate and tells, share examples.
Yeah, no, for sure, for sure. Like for example, like you have like 11, 12 years experience, and you always add a different perspective, like professional perspective into this. So we all learn a lot from that as well. So yeah, again, I'll just try to invite more professionals and also students into this platform. Let's see, like
Because trust me, then it will be like very valuable. And
hmm,
if things become valuable, people will come more and more. Like they will see, okay, there is a lot of value coming in, a lot of people coming, sharing knowledge and all. Because I can tell you, this is a very, very good idea and very good platform. Just the thing, it's not really able to achieve the goal. I feel that
yeah, yeah,
like
yeah.
it's not able to achieve the exactly how we it should, because the idea is very good. I don't know. We have to find, is it the platform is the problem, or is it like because of lack of reach to people, or what exactly is the, or something else? So
The
I
reach
mean,
is
I
very
don't know if
important.
you have interest to scale this up.
No, definitely. Actually, like I'm not focusing directly on marketing it a lot or anything as well, because like once I do my thesis, then I can give more time to this as well. But definitely, it would be great if. More people also join, like for example last time a lot of people joined, right? So it
Yeah,
depends,
yeah,
like
right.
there's like no stability. Sometimes a lot of people join, sometimes only three or four. So uh, it's
Right.
the
Yeah.
thing, yeah.
That is true. I mean, like, of course, sometimes it joins, but like, I feel like it will be more nice if, this thing is always scaling. New people are joining, and the old people are staying back,
Yeah, yeah, yeah.
and then like they are contributing. Then it's like getting more, because then everybody learns a lot, right? So
Yeah,
that's what I
definitely,
think.
definitely.
Like
So
for example, I thought today was a very interesting topic.
Yes, yes.
And if you had like more people, then they can discuss their ideas, come up. This Aditya is very active guy. I really liked his ideas and this. I
yeah,
don't know. Today he's not there.
yeah, today he's somehow not there, but generally he joins very regularly.
Yeah, yeah, he's very active. Aditya was a very active person, and then this Atmaraj I felt was very knowledgeable and also active.
Hmm.
But what I think, I did not meet anybody from like industry coming also. So that would be also one thing very would be very valuable if somebody from industry comes from a different company. Like last time, one guy came, right, who had experience in this robotics or orange or something from India.
Gray orange, yeah.
Gray orange, right? Yeah, this guy came, and that was a very interesting thing. I like that.
Yeah,
So similar thing we
he's
need.
also from robotic
Hey, there was
systems.
one thing about gray orange. I mean, just after attending the last Sunday's meetup, there is this another server called the Builders Club. So there we have on Wednesday, on each Wednesday we have like these weekly networking sessions. So we also share and discuss five news articles. So over there, gray orange came up, and gray orange is asking for $600 million in funding. So
Like
that's
on that platform.
No, 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 not on that platform. That on. I mean, it's asking. So the news is available, so anyone
Ah,
can
okay,
watch it.
the news art. Okay, yeah, yeah.
Yeah. So I found it like really intriguing, and the guys over there, I said that they are in the business of cleaning robots, but then I later realized it's warehouse management and stuff as a whole. So I did not knew that because I only learned about gray orange here itself.
Yeah, so like Aditya was also mentioning last time that gray orange was actually going into that direction. So yeah, probably
Yeah,
that is
and
the
even
reason.
Amazon is using their services to maintain their warehouse.
Hmm.
And the robots over there are also they are named as Amazon robots on the top, but the technology is, I guess, it's of gray orange. I'm not
Okay.
sure. Yeah.
No, right.
Yeah. Okay. So yeah, that's also pretty interesting. So like okay. So let's talk about now next week's session. So let's have a quick suggestions like what do you think would be interesting for next time.
I think we decided like next time we will go a little deeper into kitchen robotics, right? Like, for example,
Kitchen
here,
robots.
sorry, cleaning robotics, not kitchen, cleaning
Okay.
robotics.
All right.
Yeah.
Yeah, so like
So,
which aspect of it, like if we take this particular system, so like my proposal would be that we go into the navigation part.
I think
yeah,
the
I think
planning
this
algorithm.
navigation is more like a common thing. So, if we go here, then we can, of course, connect with this
I
particular
have I have
vacuum cleaning.
hello.
Yeah.
Yeah, please.
I have a suggestion. We can discuss where various planning algorithms used in mobile robots. That could be one topic. If anyone is familiar with some topics like Voronio map method, A star search, and like that.
Okay. Mm-hmm. Yeah, I know the planning systems, but specific to this, I don't know if there is a lot of content online. Maybe there is. I don't know. Have you checked?
I will check. I mean, it's a mobile robot, right? So we can like discuss various planning algorithms used in these robots to plan and navigate and localize themselves in the given space.
Hmm.
Yeah, I mean, that's what I told you. Like, if you begin with SLAM, then you already understand about localization.
Mm,
Because then you have to know where you are in the surrounding when you're building the map. So
Yeah.
if you finish VSLAM and SLAM, because once you have the map, then this planning algorithm will come where your path planning, right? Then the
yes, yes.
Dijkstra algorithm or other ones will come. So this would be second step. First step would be this SLAM. So navigation is an
Wait,
important part of robotics, which
I
has
have
to
a
be covered.
I have a doubt. I think I don't know about how really SLAM works, but first it will try to sense and make a map around it. Then it will try to localize itself, and then after detecting all obstacles and stuff,
Right.
then it will make a path for itself.
Yeah.
Yeah.
And
So it's like this. So no, actually, it's not really path planning in that. Basically, SLAM, it's more like it's detecting objects around it, and then
okay.
it's mapping, and then it's finding out where I am in the surrounding. So localizing. And then
Localization.
it knows, okay, this object is at this distance from me. And then,
Mhm.
so in the SLAM, it can randomly move and still can build the map.
Hmm.
So there is no need to make the optimal path planning. There is no need of that. But then after the map is there, then starts the optimal planning. So this planning algorithm comes to decide what is my optimal way of reaching this point to that point.
Okay, okay,
Okay, is
okay.
that for that you need to know the map. So the map has to be known, then it starts making optimal.
Definitely.
Of course, there are this extra algorithm also knows the destination and the
Mm-hmm.
source.
That
Then it
yes.
also has this obstacle and all. Then it
Hmm.
also plans. That's also another concept. But
Yes.
normally, if you the step would be also first understand the algorithm of how you are localizing and mapping.
Exactly. Exactly.
Yeah,
Yeah.
yeah. So yeah,
Then
once
if you
it knows the
yeah,
map, actually, then it can plan the path accordingly, right? So if there is some
yeah,
obstacle,
right,
it
right, yeah,
knows that the path
exactly,
has to go around it.
exactly. So that's what I'm saying. The mapping is the first thing. So that has to be done first. Then
Definitely.
you
Yeah.
can always go to different planning algorithms and all. So if you have a map, the robot can anyway drive from A to B. Maybe it's not the efficient way, but it will know how to drive around. But the
Yes.
thing is that the planning comes to really optimize the quickest way how it can reach from one place
Yes.
to the other.
Yes. Yes. Exactly.
So
Yes.
it's more about optimization.
Mm-hmm.
Okay, yeah. So I think, yeah, next time navigation would be interesting. So I can like keep it general to navigation, so we don't probably stick with visual slam, but we can consider all different possibilities of
Yes.
navigation and with different sensors and stuff. And
With respect to mobile robots, they
yeah,
can
with
stick.
respect to Roomba, yeah, just we will be targeting this particular case.
Yeah.
So like on
Mm-hmm.
16th we can do this general navigation, and on 23 we can dig deeper into visual slam, and there we can also talk about the algorithm of visual slam and how it actually does these key point matching and all these things. And then on
Mm.
30th we can probably go to path planning, right?
Yeah, that would be good actually that way. But then
Yes.
what happened to this theme concept? Because you
Yeah,
said
this
like
is
we were
theme, right? The cleaning robot. So it would be all will be related to Roomba. Like even when we are going
Yes.
visual slam, we would only be targeting like how would it be implemented, for example, with this system when we have this camera like this. So and navigation also we'd go for with respect to this particular robot.
that is right, but Chandan, actually, I think it's more beneficial to cover this concept in general rather than focusing only on one particular thing. So, for example, the the wheeled robots, okay, wheeled robot slam or V-slam. This concept in general is very important to know before you think how it is used in Roomba, because then you are going into a specific way of slam, because
Yeah.
it's better to understand the concept of slam or V-slam, then you go how it is used in Roomba and not the other way around. So you should not start from how Roomba did it and then you understand how everybody else does it. So you should first understand how it's really done in general. All wheeled
Yeah.
robot systems with camera, how do they navigate using V-slam, or how do they navigate using lidar or laser sensor. So so this is how normally you should start from the top, the concept, then you go into seeing okay how this concept is implemented inside Roomba.
So like for general mobile robots, you mean, right?
Yeah, general wheeled robot
Wheeled
navigation. Like for
robots, yeah.
example, let's say how total. Like I would suggest like go for VSlam with TotalBot, because TotalBot is also based on Roomba platform. Because if you think TotalBot 2 is exactly what is Roomba. So basically, it's just having the frame, but then TotalBot 2 has this Kinect sensor right on the top.
Yeah.
Then it uses that camera to do the mapping. So there you should start. From there you go to only Roomba specific, because then its camera is some kind of location and then it's doing something else. So because I don't think it's the best way to start with Roomba 980 with how VSlam works. That's not the best way, because many people don't even know what is VSlam.
Yeah, yeah,
Then because then it's like really not good, because then you're teaching
Um.
a specific implementation of a concept, and concept is always important to understand before you go to implementation.
Exactly. Exactly.
yeah. So next time it can be it can be because like we have more sessions for cleaning robots this month. Like we want to keep the whole theme of the month to be cleaning robots, but it's kind of one specific aspect of it, right? So what you are like, I agree with you that we can have like general discussion on a general topic, and then like talk specific about this. But
So what
like,
I suggest is like this, Chandan. What I would suggest to do is, so we will connect with kitchen, like cleaning robotics. That's the idea.
yeah.
But then you say, okay, the path is like this. We will cover the cleaning robots. Like for example, Roomba is using V slam and laser slam. Both they're using depending on what sensor is on which Roomba. So that's why we need to understand how laser or leader, so laser slam works, how V slam works. These two concepts. Then these two concepts are covered. After that, you go and see how this laser slam or V slam is implemented on Roomba. I think this will take less time. If you cover in the first, this Roomba concept implementation will take less time, because then you will easily understand how these are implemented in there. Okay. Then we have covered the whole navigation kind of stack. But then that would be the best way. So you say, okay, what is leader based or laser based slam? What is visual based slam? So how laser based slam works? How visual based slam works? So and then next step would be, okay, the same. So you know, then laser is sensor required, camera sensor required, and then you say, okay, in the Roomba, the laser is here located, and this is what is generating the data, and then you will easily understand, okay, this is how they do it. Not a problem. So we
Yeah.
And
can
then
begin from the first.
But you mean
after
in the same session or in separate sessions?
Depends. Like I think it's the time we are giving, like almost 2 hours. It's enough to cover these three things in the same session.
Okay, okay.
Because
after
we
uh,
will not go in deep into algorithms. We'll go more about concepts. So concept is possible to cover in 2 hours completely, all things.
yeah, yeah. After getting to know, after we are well versed with the concepts, we can then select a scenario, a random scenario where it has to uh, clean or do its task. Then we can implement those concepts as well in the
Right.
next
Yeah.
one, maybe. Yeah.
Yeah. Um, so yeah, let's go with this. Next time can be a general navigation stuff, and after that we can go to how it is applicable to Roomba, and then after that we can take this thing and go deep into navigation for Roomba, I guess, and then after that path planning, how the path planning is done, or maybe last session could be like connecting the whole thing together, right? So
If you remember, Chandandeep, last time we discussed, our goal was to pick two things. One was Roomba, the other one was this the big robot, which was external cleaning robots. If you remember, I don't
yeah,
remember the
yeah,
model name, but then that was our goal. So basically, we wanted to start with Roomba to understand like simple system, then go with the bigger one. So the bigger one should be covered before we finish this cleaning robotics session. You know,
yeah, yeah,
so
sure, sure,
keep it
sure.
that in mind. So that is important. So keep that in your theme. So that I don't remember the model name, but we discussed this model
Yeah,
last time.
sure, sure, sure. Yeah, okay. Yeah, I forgot about the bigger one. Um, okay. Then I think let's just fix the next one, and then next time we can decide whether we want to go for bigger one next one or on 30th. So yeah, so the navigation for mobile robots is what I can say for next time, right? Wheeled
And the
robots.
bigger one will also use the same concept of navigation. So whatever we'll cover next time, I think it will be also used in the bigger one also.
And so on 23rd we can go with with taking Roomba as well as the bigger one, whatever the name was, and talking specific on that case, and but
Exactly. Yeah.
next time can be general. Yeah.
Exactly. That's what the best way. So please write down somewhere so that this is the way we will go. 16 will cover navigation concept,
Okay.
and then we'll see how, if it's possible, we can see how Roomba uses, or maybe we can also take the next session completely to understand the concepts, and then 23rd we will discuss how this concept is implemented in Roomba and how it is done in the big one. So then we can compare both of them also in the same time.
Yeah, yeah, yeah. Sure, sure, sure. Okay.